Hi, guys. So we are in the final section of chapter 9. And today we're going to be talking about solving nonlinear systems of equations. So you'll see a bunch of different ways that we can solve them. So here we go. So the first technique that we could use to solve a linear system is by graphing. So when you see something like this, the easiest way to go about doing that is to just go ahead and put that into Desmos on your computer. And what we're looking for is we're looking for the point of intersection here. So if we have y equals 2x squared plus 5x minus 1 and y equals x minus 3, let's take a look and put that into Desmos. So we have 2x squared plus 5x minus 1. And then we have x minus 3. So what we're looking for here is we're looking for the point of intersection. And you can see that if we look here, these two graphs intersect right here at that one particular point, which is at -1, -4. So our only solution to this particular set of equations would be -1, -4. So what we're looking for is we're looking for the point of intersection. So if we look here, our only point of intersection, which we just saw, was right there. So our solution here is -1, -4. What we're looking for when we're looking for a system is we're looking for what the x value is equal to, which in this case is -1, and what the y value is equal to, which in this case is -4. So you can either write it that way or you can write it as a point. Doesn't matter. Let's take a look at one or two more of these. So let's look at the second one, which is y equals x squared plus 4x minus 4 and 2x minus 5. So I'm going to get rid of these. X squared plus 4x minus 4. And then our second equation was 2x minus 5. So if I'm looking for the point of intersection. There's only one point again here in this one, and that happens to be at -1, -7. So my only solution to this particular system would be at -1, -7. Now, both of these only have one solution, but it's possible that you can have more than one solution. Okay? So let's take a look at, say, our third one, which is 3x minus 15 and x squared minus 2x minus 7. So 3x minus 15 and x squared minus 2x minus 7. I think I wrote one of them wrong. 3x minus 15 and x squared minus 2x minus 7. So we're looking here, guys, at this particular graph. You'll notice that they don't intersect anywhere. Okay, so in this particular system of equations, there's no solution because these graphs are not intersecting anywhere on our coordinate plane. So this would have no solution. So what you're looking for is you're looking for that point of intersection. Sometimes there's two solutions. So say I change this a little bit. Maybe I make this 3x plus maybe something like this. You'll notice here we have two solutions. We have a solution here where we have a point of intersection and a solution here. So you can have no solution, you can have one solution, you could have two solutions. It all is depending on where those point of intersections are occurring. Let's keep going. Again, here are the graphs. Now, we have another way that we could solve these, and this is by substitution. So if you remember back to substitution, we had systems. What we're doing is we're substituting what this y is in over here. So when we substitute that in, what we're going to end up getting, -2x plus 3 is equal to x squared plus x minus 1. Now let's solve this. So I have to set it equal to 0, add the 2x to both sides, and I'm going to subtract the 3 to both sides. So now I'm going to end up getting 0 is equal to x squared plus 3x minus 4. So now you can think to yourself, okay, I have a quadratic. Let me think of the different ways I could solve a quadratic. Easiest way is to factor. So I'm going to see if I could factor this. If not, I'm going to have to use quadratic formula or go in a different technique. So let's use factoring because we can find something that's going to multiply to -4 and add to +3. That would be 4 and -1. So this will factor to x plus 4 times x minus 1 is equal to 0. Using the zero product property, set both of these equal to 0. Add 1, and you're going to get x equal to -4 and x equal to negative. Oops, this is going to be subtract that. X minus 1 equals 0. So this is going to be x is equal to a +1. Now, you're not done though, because your solution to all of these is a point. So when you're asked to solve the system, the solution is a point. So we need to find the y values to both of these x values. So how are we going to do that? We're going to plug in our x values back in. So we know that y is equal to -2 times -4 plus 3. So y is going to be equal to 11. So I'll have a point at -4, comma 11. Then I'm going to plug in a +1. Y is equal to -2 times +1 plus 3. So y is equal to +1. So I'll have another solution at 1, comma 1. And those would be my two solutions. Now, I could solve this by graphing if I wanted to. So if I want to go back to Desmos, and I have x squared plus x minus 1. So I have x squared plus x minus 1 that I could graph. So let's graph that. X squared, x minus 1. And then our other function was -2x plus 3. -2x plus 3. Look, we have a solution at -4, 11, which we got, and our other solution at 1, 1, which is the 2 points of intersection. So obviously Desmos and graphing is the easiest technique here, but you're not always going to have the luxury of using Desmos. You could use a graphing calculator as well, but obviously you might not have a graphing calculator, so it's important to use some of these other techniques as well. So that's how substitution would work. But again, you can always just check your answers using Desmos. Now we also have another technique, which is elimination. So remember, with elimination, you want to eliminate one of the variables. So I know if I take a look at both of these, I can just subtract these two equations, and the y's are going to cancel out. And then what I'm going to be left with is x squared minus nothing is going to be x squared. -3 minus a -3 is going to cancel out as well. And then -2 minus 8 is going to be a +6. So I end up getting x squared plus 6 is equal to 0. And then I can go ahead and I can solve that, okay, using square roots. So I'm going to get x squared is equal to -6. And let's take a look at what happens here. So let's graph these. Y equals x squared minus 3x minus 2. So x squared minus 3x minus 2. And let's take a look at -3x minus 8. And if we take a look at both of these, you'll notice that this is another one of those cases where they're never crossing, which should make sense to you because when we try to solve by elimination, we end up getting x squared equals a negative, which we know that that can't happen because x squared can never be equal to a negative. So we end up getting no real solutions here. And we can see that by both looking at the graph, because there's no intersection, and by trying to solve this using elimination. Okay, so when we're using any one of these techniques, remember substitution, you're taking this value and you're plugging it in there. Elimination, we're trying to eliminate one of the variables by easiest way, subtracting both of these, and then we can get rid of the y's every time. But again, we could use graphing to help us in any of these cases. Here, we're asked to approximate the solutions of the system to the nearest thousandth. So again, we're going to solve this by graphing. So we're going to take a look at Desmos again. So 1/2 x squared plus 3 and 3 to the x. 1/2 x squared plus 3 and 3 to the x. And go to u, 3 to the x. So obviously these graphs are a little bit different, but we're looking for that point of intersection. And here's that point of intersection. You'll notice that it's a decimal. So we want to round that. And it said round to the nearest hundredth. So that's 2 decimal places. So our solution is going to be 1.19 comma 3.71. So our solution, which we see right here, 1.19 comma 3.71, or it says thousandths rather, so we'll round to 3 decimal places. So 1.194 comma 3.713 is your solution. Let's look at example 5 here, which is very similar. But when you have two things equal to each other, you're just going to graph them separately. So you're going to treat them as if it's a system, where you're graphing them as two separate equations, and we're going to see what they end up equaling. So we're going to graph negative 2 times 4 to the x plus 3. So negative 2 times 4 to the x plus 3. And then we're going to graph our right side, which is 0.5x squared minus 2x. So 0.5x squared minus 2x. This, we can see, has two solutions. They're crossing at two separate points here. So one of my solutions is at negative 1 comma 2.5, and the other solution at 0.468 comma negative 0.827. So even though they're set equal to each other, we can just graph them separately, and we'll get our 2 points of intersection there. Okay? So our two solutions in this case, again, were negative 1 comma 2.5, and then 0.468 comma negative 0.827. This is showing you on the graphing calculator how you can go about doing that. All right, so that's all for this lesson. Make sure the key thing here, know the different techniques. So you know how to solve by substitution, you know how to solve by elimination, you know how to solve using Desmos and graphing, which will be the easiest technique for you to use. One key thing, when you are using Desmos, make sure that you're specifying that you're using that and you're looking for the intersection points. Remember, you can have one point of intersection, you could have no intersection points, in which case there's no real solution, or you could have 2 points of intersection like we do here. Good luck, guys, and if you have any questions, come to the Google Meet. See ya.